All right, we are about to begin our notes on page 36. Ignore that page 36 in 1.8. And we are going to look at some of these linear functions in context. So it's always important to read what you're given. So the data below gives the average cost of annual tuition and fees at four-year public universities adjusted for inflation to $2018. So if you notice, we've got our years since 2000 and we've got our tuition in 1,000 or in thousands of dollars. This top row refers to our X and the bottom row refers to our Y. But when I notice when they write it in function notation, they use this. And so what's happening is X is actually our T, our time in years, and our function is just the price. So just some little notes off to the side. All right, so we've got this function, f of t equals, then we got all these decimal numbers. So we're going to use this equation to answer the next couple of questions. So according to your model, what was the average tuition for and fees for four-year public universities in 2014? So they give us a time, and remember, time is since 2000. And so if it's 2014 that we're looking at, our time is going to be 14. Now you will want your graphing, a calculator. The graphing calculator works really great here. So if you haven't done so, pause the video, go grab one. But otherwise, this is, X or T is 14. And so I'm going to put that into my equation. And then I always like to see work, but absolutely let your calculator help you. So the first thing is, if we are dealing with, what's the word? Order of operations, we do our multiplying first. So with my calculator, let me see if I can get it moved over here. Let's see, I'll be taking 0.242 times 14. So that gives me this number, 3.388. I got to write it down. The calculator is going to disappear as I do that. And then to that, I want to add the 6.237. So I can just go back to the calculator, hit plus, and just put that decimal in there. And then this is my answer, 9.625. So let's talk about what this number means. So first, I'm looking for tuition. And so the first thing I'm going to do is actually turn this into tuition dollars. So I'm going to take this and I'm going to multiply it by 1,000, which turns my tuition into $9,265. So that's how much tuition and fees they would have expected in 2014. The next thing I want to talk about is how we need to start looking at the best way to be writing our answers. So this is great. We've put a unit of measurement to it, put a dollar sign, but we need to start going back to our function notation. So our function, if our time is 14, then our cost is $9,265. So those of you who are planning to go on into Honors College Trig, or maybe you're currently in it, or you're going into calculus, they're also going to be looking for what I put in the box. All right, let's do the next one. So according to your model, what will the average tuition and fees be in 2023? So the same type of problem, except now 2023 is 23 years later. So I'm going to use the same equation. Put my 23 in. And then you can take a moment, you can type that into your calculator. And when you're done, you get 11.803. So again, this is our tuition. Tuition does not cost $11, and if I rounded that, 80 cents. So what again I have to do is multiply that by 1,000, and I'll realize that tuition is actually $11,803. And again, that's a great answer. We put a unit of measurement. If we want to write it in function notation, then my function, when the time is 23 years, I will have a tuition of $11,803. So both are great answers. I just want you to start getting used to seeing different ways to write it. All right, now we're going to switch it up. According to your model, when will the average tuition and fees first reach 20,000? So here I'm actually looking for the time. So I'm going to put 20,000 on the other side of the equal sign and leave my function with the t in it. And then again, it's always great to have a calculator with all these decimals. So the first thing I need to do is realize that this 20,000 is probably not, excuse me, what I want, because this equation isn't built for 20,000. So now what I'm going to do is divide my 20,000 by 1,000, and that number turns into 20. And so now I can go about getting x or t alone. So the first thing I'm going to do is subtract that 6.237 number, which gives me this. And now to get t alone, I'm going to divide by that 0.242 decimal value. And when I'm done, I get this. And so, that's about 56, 57 years from now. So somewhere around 2056 is what I'm looking for. Now, going back to that function notation, I would say my function, I'm going to switch to the same color, keep that going. If my t is this exact decimal, would give me a tuition of $20,000. All right, let's go and talk about the next two questions. So what is the y-intercept? Remember, the y-intercept is b. B is by itself. That b value is that 6.237 right here. Remember, that's our beginning, so it's our beginning amount because it's the y-intercept, and y represents tuition. And if this is the beginning, this is when it started in 2000. So realize that tuition, again, wasn't $6.24. If I take that times 1,000, my beginning tuition in 2000 is actually $6,237. All right, what's the slope? So remember our slope, m is married to the variable. In this case, it's t. And if we go back to our martini problem, that means the y's are on top, the x's are on the bottom. The y is our tuition, that's our money, and our x is our time, that's our years. Again, tuition is not changing by 24 cents every year. If I take that times 1,000, I get this value. And now when I want to explain it in context, tuition, this is one way to say it, increases $242 each year. This whole thing was about tuition and how it goes up from year to year to year. It definitely doesn't go down. All right, let's go to the next one. So on this one, we've got our equation. So let's read what it says. The data below gives the number of Netflix subscribers in the United States for various years since 2000. So again, we have our x, which is our years, and then we have our y, which is subscribers in millions. So 7.48 million, 12.27 million. And then they gave us an equation that follows that data. And again, this is the years since 2000. All right, using correct units. Again, let's explain what the slope is. So the slope is that number married to x. This is, excuse me, in millions. So now what I'm going to do is take this number times a million, and that turns that into 4,829,000. All right, let's put this with our y's and our x's. So y and x, y is the number of subscribers, and x is the year. And so now if we want to put it in context, I'm going to kind of run out of room here. Let's get rid of that screen. So the number of subscribers increases. I don't have a lot of room here. 4,829,000 each year, or every year, for instance. All right, next, according to your model, how many US subscribers did Netflix have in 2014? So remember, our equation is since 2014, so that means our time will be 14. So I can go back to my equation. I want to grab a calculator, put 14 in for T, and then I would go about typing that in, and once I do that, I get this number. And you could leave it like this and say 246.885 million subscribers. You could take it times a million, excuse me, and have this number instead. So subscribers, put a unit subscribers, put a unit of measurement. If we're going to keep with the whole function notation, my function when my time is 14 gives, and I'm going to write the decimal, so I'm going to write in the space I already wrote on. All right, next one. According to your model, how many US subscribers will Netflix have in 2050? So this time our time is 50. Same process. SC. And once you type that into your calculator, whoops, I just realized, okay. Sorry, I was looking at my notes that I already wrote. So this, whoops, is actually the answer for down here. So sorry about that. If we had typed this into our calculator, we would have gotten this number instead. So 73.041. So 73.041 million subscribers for C and 246.885 million subscribers for D. Apologize about that. Yeah. All right. According to model, when did the number of US subscribers reach 20 million? So now I'm going to look for T, and I'm going to put the 20 as 20 onto the other side where Y would go. And now my goal is to solve for x. So first I'm going to subtract by that 5.435. That gives me this number, 14.565. And now to get t alone, I'm going to divide by that 4.829 number, and I get this. That's about 3 years, so somewhere in about 2003 this happens. So again, function notation. My function, if x is this value, gives me a value of 20 million. And finally, one more. According to your model, when will the number of US subscribers reach 125 million? So again, like E, put 125 in for Y. You will do the same steps as E, getting the T by itself. So again, you're going to subtract the 5.435 value first. And then you're going to divide by T, or I'm sorry, not by T, by the 4.829 value, and you get this. So it's about 24, really close to 25 years, but in the year 2024. Going with function notation, my function, if x is this value, or in this case T, I would have 125 million subscribers. All right, those are our word problems. I'm going to do a second video for page 38, and you definitely need to watch this video. So I'll talk to you in a moment.